In this publication, we propose a novel solution to the problem of deforestation, the Direct Measurement Forest Carbon Protocol, or the DMFCP, resulting in a commercial scale process for the first of its kind forest carbon products. Our results are relevant to forest communities, landowners, policymakers, and carbon market participants. We use archival data for forest carbon to show how the DMFCP operates in the field, resulting in revenue to landowners. Deforestation is a threat to humanity and biodiversity across our planet right now, and diminishes the whole of nature for future generations. There's no stopping it. Deforestation continues nearly unabated in the Amazon, for example, and in forests across the planet, erasing culture, biodiversity, and precious ecosystems. Carbon markets based on trading of forest carbon credits have been ineffective in solving the problem. Currently, forest carbon offsets are based on estimation methods that cannot fully account for forest carbon, unavoidably introducing errors, including potentially invalidation and overcrediting of financial markets. The DMFCP solution overcomes the problems of estimation-based protocols, resulting in a complete, measurement-based, field-deployed system of systems for CO2 and related greenhouse gases. We identified 25 differences between estimation-based protocols and the DMFCP, including, importantly, uncertainty for both approaches. The primary feature of the DMFCP operation is direct measurement of CO2 flux in the forest using the eddy covariance method to determine net ecosystem exchange, or NEE. NEE is a universally accepted scientific method to track forest carbon. Without the fundamental terms for photosynthesis and ecosystem respiration, forest carbon cannot be reliably determined or subjected to third-party verification. The DMFCP directly measures forest photosynthesis and respiration and is subject to verification every half hour, in contrast to every 6 or 12 years for estimation-based protocols. Each forest project or node is comprised of a global monitoring platform and organized in a system of systems architecture. The system of systems automates collection and analysis of data, uncertainties, creates data product, schedules third-party verification, and flags performance issues across the array of hardware sites and software operations. The DMFCP is designed for turnkey forest deployment anywhere on the planet. The objective of the DMFCP is to generate rapid revenue to forest landowners on the spot in the forest. We do this by structuring the process in 3 steps. 1. Define physical carbon by deploying eddy covariance equipment, verifying CO2 flux. This is the material content of the project and cannot be accomplished remotely or by estimation. 2. Compile project carbon. This is the amount of carbon stored across the spatial and temporal domain of the project. And 3. Transform project carbon into financial carbon. Financial carbon products are tons of CO2 equivalent, monetized, and placed in portfolios representing diverse ecosystems and available for sale to consumers and voluntary and compliance buyers. The entire process can be tracked online by cell phone on a daily basis. The DMFCP empowers landowners with near real-time financial forest carbon accounting on the ground, establishing fundamental asset value and pricing for forest carbon, incentivizing forest preservation over deforestation. The DMFCP business model does not impose an upfront cost to landowners, which is a hallmark of estimation-based protocols, but in contrast, provides an upfront payment to the landowner plus royalty on sales of annual carbon products also paid to the landowners. The DMFCP improves existing protocols based on estimation, including California Air Resources Board, Climate Action Reserve, the American Carbon Registry, VERA, and the Clean Development Mechanism, and policy platforms such as the Paris Agreement and the Reducing Emissions from Deforestation and Degradation, or RED, which is a UN program. These existing protocols have proven to be ineffective in stopping deforestation. They can't be verified readily and are cumbersome and expensive for landowners. Existing protocols do not actually measure CO2 at any time or account for soil or ecosystem respiration as CO2 emissions. This is a primary determinant of net forest carbon sequestration. Without a true net carbon accounting, there can be no net benefit to the atmosphere or a reduction in global warming. Calling these protocols into question with regard to their efficacy and expense to provide a solution to deforestation. We illustrate the DMFCP operation and results with archival data from two sites, the Harvard Forest in Petersham, Massachusetts, and the Nkasa Park Reserve in Ghana, Africa. These sites are distinct ecologically. The Harvard Forest site reflecting temperate forest species, and the Nkasa Park site representing tropical forest species. The NEE records for these sites are also unique, but both are in fact constrained by the opposing CO2 fluxes of photosynthesis and respiration. Both sites also represent different opportunities to monetize NEE, reflected not only in their species composition, but in the land use history, climate change, and continuing anthropogenic effects. But when pooled in a portfolio, these projects offer unique benefits and a buffer to risk. For example, while the Harvard Forest NEE was severely reduced by drought in 2010 to about 0.59 tons of CO2 equivalent per acre, the Nkasa site in 2011, the first year of that time series, sequestered a whopping 15.2 tons CO2 equivalent. Taken as a pooled portfolio, the Nkasa NEE buffered the Harvard Forest loss in NEE. Pooled portfolios can be designed to manage annual variance as reflected in conditions of governing contracts. This approach, if practiced in the field, would erase the difference between voluntary and compliant market carbon pricing, since all the products are directly measured. We emphasize that incorporation of biodiversity could and should be coupled with NEE, methane, N2O, and other factors, including land rights of indigenous people. Biodiversity products enhance the revenue in our projections by up to $16 million and $8 million for the Harvard Forest and Ghana site, respectively, over the project periods studied and over the periods projected. These projections were about 5 times on average that reported for typical voluntary market revenue based on estimation protocols. In conclusion, the DMFCP is an alternative to existing ineffective forest carbon accounting. It is available and ready for immediate deployment anywhere on the planet. This includes application to about 2 billion acres of deforested and degraded land worldwide. The DMFCP primarily benefits forest communities and landowners as well as humanity by incentivizing forest preservation over forest destruction. The system of systems concept advances technology adapted for use in forests and by people in the forest to decrypt the enigma of deforestation, now and for future generations.